Hello everyone. In today's session, we'll be starting with something new, and that is joint equation of pair of straight lines. Frankly speaking, pair of straight lines was never in the syllabus before in competitive examination. It used to come subtly. But the thing is that you cannot start directly in the examination. So let us have some small sessions on joint equation of a pair of straight lines. Now, when I say pair of straight lines, I'm expecting two lines. Okay. So we will have to write a general equation. So we are expecting a second degree equation. General equation of second degree I have written. Why second degree? Because two lines are expected there. Because as we are looking for joint equation of pair of lines, as I said. So should we not start straight away as suppose two lines are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. We want combined equation. So what else? You just multiply those two. a1x plus b1y plus c1 and a2x plus b2y plus c2. When you multiply, what type of terms are expected? When you will actually multiply term by term. A term of x square you are expecting, product xy you are expecting, y square, single degree term in x, single degree term in y, and perhaps constant. So will it not be of the form something into x square, that is ax square, plus 2hxy, product xy term, plus by square, plus 2gx, plus 2fy, plus c equal to 0. Some of you may wonder why I'm writing there 2g, 2f. It may also have some meaning. Let us not get there. Just try to understand the form. Form is important, right? Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now, I started with a1x plus b1y plus c1 equal to 0 and the other line, and joint equation would be of this form, I said. That does not mean every equation which has terms of x square, xy, y square, x and y and constant will represent line. That doesn't happen. That may represent some other curve also. But if you want that to represent pair of straight lines, then some particular condition would be required. And the condition is that if it has to represent pair of lines, then condition says I'm using for the entire expression name as delta, and that expression is ABC plus 2FGH minus AF square minus BG square minus CH square. Now this entire expression's value should be 0. Means if you are given one equation in which that A, B, C, F, G, H, etc. are available, substitute the respective values here, evaluate that value of delta. If that turns out to be 0, then that equation represents the joint equation of straight lines. This is how we would proceed. Okay. So let us proceed for the next. Immediately, one illustration at least we should try, because how we will substitute otherwise values of A, B, C, etc. So for what value of k, the equation kx square minus 10xy plus 12y square plus 5x minus 16y minus 3 equal to 0. This is equation given to us, which is actually of the form ax square plus 2hxy, etc. Now, we want this to represent pair of straight lines, and we are expected to evaluate k. Now, I am not taking question in that multiple option question. Let us just find straight away k. Use what is coefficient of x square that we have named as a. So that is nothing but here k. 2h term is minus 10. 2hxy, right? So 2h is minus 10. So h is minus 5. G, F, C, all can be written. Substitute all that in delta. And finally, if this given equation has to represent pair of straight lines, then delta will have to be 0. And use this condition to evaluate finally k. That leads to k equal to 2. I mean, expression looks quite cumbersome. But once you apply, things are actually pretty simple. Like value of k just turned out to be 2. Now, from here, we go to next. And we take now pair of straight lines through the origin. In previous part, when you are having ax square plus 2hxy, etc., that big equation what you saw, there my initial step was ax1 plus by1 plus c equal to 0. That was one equation of line. And a2x plus b2y plus c2 equal to 0 was the other equation of the line. So obviously, the form with which I started was not representing lines passing through origin. If lines are passing through origin, both the lines, then what? This is how we have to start. Now, picture would look something like this. I mean, like whether it is required for the problem or not, just keep that picture ready in your mind. I am saying two lines passing through origin. So you can always draw x-axis, y-axis, origin and two lines passing through origin. What type of equations you will write for those two lines? Y equal to m1x, y equal to m2x. That is what is expected, correct? I want joint equation. So obviously I can write m1x minus y into m2x minus y equal to 0. Simplify. A term of x square would appear there, term of xy would appear there, and term of y square would appear there. X square degree 2, xy degree 2, y square degree 2 means each term is of degree 2, right? So what we observe is that y minus m1x into y minus m2x equal to 0 would lead to one equation which is of the form ax square plus 2hxy plus by square equal to 0, right? And also, as I said, since each term had degree 2, so this is going to be homogeneous equation in x and y. Okay, so not necessarily every time you would be given that y equal to m1x and y equal to m2x are the equations with which you have to start. I explained to you in that manner, but actual when you sit for the problem solving part, you would be given directly equation ax square plus 2hxy plus by square equal to 0. And from there perhaps we may have to find out actual equations of the line, right? And for that, I can always take that as that if ax square plus 2hxy plus by square equal to 0, if that has to represent two lines y equal to m1x and y equal to m2x separately, then can't I write m1 plus m2 equal to minus 2h upon b and m1 m2 equal to a upon b? Why I'm saying so? I mean, stretch your mind and try to get the answer. Y equal to mx, that is the form. So y upon x would be m, right? Both the equations would be of the form y equal to mx and y upon x is m. If I am saying so, so I can always write ax square plus 2hxy plus by square equal to 0 in the form by dividing x square everywhere and replace that y upon x as m. So you will get actually a quadratic equation in m and hence two roots of m. One would work for one equation and other one would work for another equation. So m1 plus m2 would be minus 2h upon b and m1 m2 would be a upon b. So the moment you see equation, you must be in position to write m1 plus m2 and m1 m2, and if required, finally you would solve for m1 and m2. That will depend on the problem which you are going to solve. Okay. Now two straight lines, ax square plus 2hxy plus by square equal to 0. Now there could be a possibility. What type of lines you are going to get? First is real and distinct if h square minus ab is greater than 0. Now why I am saying so? That answer lies actually in the fact that m1 plus m2 and m1 m2, they had come from one quadratic equation in m, right? And hence apply your knowledge of quadratic equation. If you want to have real and distinct roots, then discriminant will have to be greater than 0. And the discriminant actually has in it that h square minus ab, correct? So h square minus ab greater than 0 for real and distinct lines. For real and coincident lines, now this goes without saying, h square must be equal to ab. And for imaginary lines, we expect now h square minus ab to be less than 0. I don't think any explanation is required here. Okay. So let us move for some illustration based on this. Okay. So if the equation 2x square plus lambda xy plus 2y square equal to 0 represents a pair of real and distinct lines, then find lambda. Now see, real and distinct lines, this actually is the clue. When would this represent real and distinct lines? When h square minus ab is greater than 0. What is h? 2h is coefficient of xy. So what is h here? Lambda by 2. And what are a and b? They are nothing but 2 and 2 only. So substitute h square minus ab greater than 0 in it, lambda by 2 and 2 and 2, and you get finally lambda square minus 16 greater than 0, which is of the form lambda square greater than 16. We have solved inequations where x square greater than a square. We have seen this before. Solution was x is less than minus a or it is greater than a. This kind of thing we have already done. Please revise your things and you will be able to get answer for this, that lambda would be less than minus 4 or lambda would be greater than 4, and hence lambda belongs to minus infinity to minus 4 union 4 to infinity. I hope length of the solution, though it is short, but your concept should be clear. Then perhaps you will be able to write such a short and sweet solution. Let us take one more illustration. And the next illustration is, if one of the lines given by 6x square plus kxy plus y square equal to 0 is 2x plus y equal to 0, then find k. Now one of the lines is given to you. Other one we do not know, but we have to find k. Now, if given equation you use for writing auxiliary equation means divide by x, y by x, you replace by m, so get one equation in m, that is called auxiliary equation. So 6x square plus kxy plus y square equal to 0. From here, if you want to write auxiliary equation, what would be auxiliary equation? It would be m square plus km plus 6 equal to 0, correct? Now, what type of two roots you are expecting for m? 1, which is already given there. 2x plus y equal to 0 is one equation of the line. So what is corresponding m here? Minus 2. Okay. So this minus 2 will surely satisfy this quadratic equation in m, which is m square plus km plus 6 equal to 0. And if I substitute that m equal to minus 2, I will finally get k as 5. So question was regarding finding k only. So we have found answer for k. Now here I finish my session. When we meet next time, again something maybe in short we will be doing on pair of straight lines. Hope you enjoyed this session. If you have liked the video, please click on this side to subscribe. And if you want to place an order for the book, please click on this side. Thank you.